Our next presentation is called Mounting Motorcycle Legends. Ania Golebiowska is a textile conservator at Zenzie Tinker Conservation. Among many varied projects at Zenzie Tinker Conservation, Ania has worked on royal funeral effigies for Westminster Abbey, the Solebay tapestry for the Royal Museum's Greenwich, and mounted clothes belonging to the photographer Lee Miller at the Brighton Museum. Mike Penwolf is of Panotechnia. He has a varied career including prop making, CAD design, interactive exhibits, and museum mount making. He has worked with almost every material with a recent emphasis on metalwork, expanding his engineering workshop skills to include welding. Unfortunately, Mike will not be available for the Q&A part.
Hello, my name is Ania Golebiowska and I'm a textile conservator from Zenzie Tinker Conservation in Brighton. Together with Mike Penwolf from Panotechnia, we'll be presenting Mounting Motorcycle Legends. In 2020, in the middle of the COVID-19 pandemic, Zenzie Tinker Conservation in Brighton, UK, was approached by the Isle of Man's Manx Museum to conserve and come up with an innovative way to mount racing leathers from the island's iconic tourist trophy motorcycle races, the TT, over historic motorcycles from the collection. For the first time in history of the museum, there would be a permanent gallery that tells the stories of everyone involved in the race, from riders to volunteers, mechanics to marshals. The gallery opened in May 2023, just in time for that year's TT races. For context, the Isle of Man is a very small, located in the Irish Sea between Great Britain and Ireland, and is not a part of the United Kingdom but a Crown dependency. The history of the road racing started there in the very beginning of the 20th century, with the inaugural race taking place in 1907. The current route of the race is marked in red on the picture on your right. It's important to mention that the 38 miles long course runs on the public roads, which are closed for the 13-day duration of the event. Each lap has 219 turns, and the current record is set at 16 minutes and 36 seconds, with an average speed of 136 miles per hour. This incredibly dangerous but picturesque race has an iconic status worldwide among motorcycle enthusiasts. It is also very important to the island's identity and has an enormous cultural and economic significance. On this slide, you can see some of the examples of the objects we had in the studio, various racing leathers and associated accessories. Most of the modern motorcycle leathers are all-in-one garments with center front opening from crotch to neck with snugly fitting legs and arms. What makes their mounting very tricky is that restricted access, even without added challenge of the dynamic racing positions requested by the museum, and supporting the mount safely on historic machines. There is no time to discuss the various conservation issues, but many of the objects required treatment before mounting and their condition influenced our decision-making process. I would also like to mention that even today, the racing leathers rely on flexibility and strength of the leather as the main protective material, but through the 20th century, with increasing additions of modern materials like Kevlar and various foams and plastics that age and break down in an unpredictable way. To say the least, there was a very difficult task ahead of us. After much discussion, we created a list of requirements for the mannequins. Inert construction from known conservation-grade materials. Supportive and safe for permanent display. There is no rotation objects in the Manx Museum collection. Each motorcycle and each leather belong to one specific race, one person, and one unique moment in the history of the TT. Fixed simply, in non-damaging ways, onto the motorcycles which are all accessioned objects themselves. Be physically stable enough to be mounted or tilted motorcycles in dynamic racing positions. Once locked in position, they needed to be rigid enough to lift on and off the motorbikes to allow routine maintenance to avoid engine seizure. Be adjustable in very precise ways via very restricted access given by the motorcycle leathers. Also be adjustable once in position on the motorcycles, be made and padded in a modular way while being able to have bespoke adjustments. The whole project spanned around 2 years from the initial contact to the installation of the display. Also during that time, we all experienced the global COVID-19 pandemic. In January 2022, the travel restrictions relaxed enough to allow us to go for one and only site visit. We were finally able to meet the museum staff we knew from Zoom meetings. We were able to see the gallery under construction, but most of all, we could see and measure all the motorcycles. Now I will pass it on to Mike, who will describe the process of creating the metal skeleton.
Hi, I'm Mike Penwolf and I'm a design engineer. So when I first was asked to do this, I thought this is going to be really difficult with one-piece leathers, but anyway, let's give it a go. So the first thing I did was borrow a skeleton from a friend of mine so I could actually see where all the real joints are in the human body, and then which one of those I would actually need to make the mannequin get into the positions we needed on the motorbikes. Obviously, the most difficult decision was how to control the joints at the elbows and the knees, because we wouldn't be able to get to them once the skeleton's inside there. So I thought about the kind of joints we would need, realised that ball joints were going to be the favourite, and had a look around to see if I could buy anything that was ready-made as a remote lockable ball joint, and there aren't any and that I can find. So I realised I'd have to invent something, so then I just thought about it and came up with an idea. So that's what I did. Weight was going to be quite an important issue. We had to make it as light as possible, so aluminium was obviously the favourite choice for that. There's a downside to that aluminium sheds its kind of outer layer all the time as you're touching it, so we knew we'd have to get that anodised. In this case, we had it anodised in black. But there was another problem. I needed to learn how to weld aluminium, so thank goodness for YouTube, managed to get that sorted. I started off by drawing out the mechanics of it on a Fusion 360 CAD program, so I could simulate the actual movement of the joints and see how much I'd need to cut away various components to allow for the movement, and that would let me sort of work out exactly how many components and what size precisely they'd need to be. So that was a really useful part of the process. So you can see on this slide where Ania's using an Allen key to lock the bolt that's at the very end of the leg, and then that bolt is controlling the sort of rod that runs right up to the knee and presses up against the ball and sort of locks it off. So that just means that you've got access to that while the figure is on the motorbike, and you need to do fine adjustments. With the boot off, you can adjust the leg into exactly the position you want. And then once that's locked off, we could put the boots on. I think Ania's going to explain that. I made most of the sort of bones, if you want to call them that, in a form that could be adjusted in length to save me having to make individual ones for every figure. So apart from one figure who was a slightly shorter chap, I made special ones for him, but all the others were interchangeable. And so to do that, I drilled holes in the sort of inner bone cylinder, and had 2 holes on the outer one, and I just adapted a spring clip by adding some bolts to it, so that you could just clip it on. Trying to make it as simple as possible, tried to make it so that we could use one Allen key to do pretty much all the adjustments to keep it simple. This was the hardest part of the fabrication, was creating the caps and the pistons that held the ball joint. So all of this had to be made from scratch, and that's where the welding came in, having to sort of machine the end of the cap with the correct radius for the stainless steel ball, and then weld it on afterwards onto the tube, and then cut away that slot that you see. And then there's the actual sort of piston part that presses up inside the cap, and so that all had to be machined to the same radius. The only off-the-shelf element was the actual steel balls, which I managed to find from a company that was making them for doing decorative balustrading, and they had exactly the right size ball that I needed, with a pre-drilled and tapped hole in, so that saved me a massive amount of work. So here, looking at the hips, which were essentially the same as the shoulders, you can see that there's a ball joint on the end of a very short limb that's really the hip joint, and that is being held by a clamp so that I could move them in and out to adjust the width of the hips, but also control the kind of rotation. So if you've got a figure that's really bent over to an extreme angle, you could rotate those around, and that really helped with being able to get the legs into any position.
The Conservators challenge was how to pad the aluminium skeleton made by Mike in an appropriate way. We had to design and create adjustable padding to adequately support the leathers in the dynamic positions, simulating the riders' bodies and specific racing styles instantly recognizable by fans around the world. We also needed to always leave access points for the joints. The modular system evolved over a 14-month period, being gradually improved with final tweaks even happening during the installation fortnight. During prototyping phase, we tried several more complex systems of padding, only to settle on a quite simple wrapping technique, both for speed and ease. We used strips of polyester wadding wrapped around the metal bone, once set to the right length. To prevent polywadding from spinning, the first layer was anchored with Velcro. Gradually, the musculature of the mannequin were built. On this slide, you can see various stages of creating the legs. Force-shaped elements were added for extra rigidity on the outside of the thigh and upper arm. Once padded to the required shape and size, limbs were covered in cotton jersey with a drawstring placed top and bottom. During one of the trial dressings, we realized that we need much more accentuated knees and elbows for them to create the right shape through the thick, heavy leathers. We couldn't simply build on top of the padding as we would normally do, because we needed to avoid any wadding becoming entangled in the metal joint components. So we made additional pads rather like the shape of fried egg, stitched on the already padded and covered limbs. Even though these legs might not look anatomically correct, they served their function well once inside the leathers. Mike made hands using aluminium armature wire welded onto an aluminium plate. They were attached to the arm via a ball joint at the end of a tube, overlapping the grooved end of an arm. So a retaining bolt could engage and lock off in the groove at any rotational angle needed. To pad them, we used a similar wrapping technique, using strips of polyester felt covered with fingers cut from the white cotton gloves. Additional pads were stitched to create the top and palm of each hand. Each of the fingers bent to allow the illusion of gripping the handlebars. Depending on the type of bird, replica or museum object, feet were made from either stainless steel bar or a cedar wood form taken from shoe trees and shaped by carving ethafoam pieces and polyester pads. Then, everything was contained in a jersey tubing. The feet had a ball joint at the end of a tube with a spring-loaded bayonet mechanism, which attached to the end of the leg. This meant that after the leg has been locked off in position, the boot can be pressed into the leg. Our bigger challenge was creating the torso. It had to be fully supportive of the heavy leathers, have some flexibility to allow the dynamic positions, and allow us to full access to the spine, shoulders, and hip joints for the necessary adjustments. We considered several different options, including using metal boning that didn't work. We therefore settled on making an upper back from layered fosse shape and fixing it to the spine by stitching through the pieces of ethafoam. It worked well, but it didn't seem enough for permanent display, and we didn't have the required rounded shape. We needed something able to move with the spine while simultaneously being flexible and strong. After extensive testing, we created an outer shell made of laminated acid-free card we refer to as armadillo, so you can guess where we got our inspiration from. To feel still quite hollow torso, we made numerous polywooding cushions in 3 different sizes that allowed us to fill the voids and create the right shape. For 8 dynamic mannequins, we made more than 200 cushions. Last but not least, the helmets. Mike created an adjustable neck stalk that fixed to the end of the spine. The helmet mount was attached on and positioned, allowing the head to be angled as required. As you can see in the image on the right, subtle differences in head angles were surprisingly effective in making the mannequins seem like real riders. We faced many physical challenges while working with these mannequins. Most difficult was the lack of conventional mannequin stand, because we aimed to work on them in a pose as close to the final position as possible. Here you can see a few images showing different types of hanging mechanisms, as well as a motorcycle made by Mike from scaffolding poles to help us achieve realistic poses. It's worth mentioning that every change in the position of the mannequin radically affected the shape and placement of padding. Here is a view of finished mannequin undressed and dressed in our studio in Brighton before shipping to the Isle of Man. Installation was the first opportunity to try our mannequins on the real motorcycles. For the whole project, we had worked in isolation with only one site visit to measure the bikes. We were all asking the same question: will the mannequins look convincing enough? The installation process took 13 days for 8 dynamic mannequins and 2 static ones. Our team of 3 from Brighton was made up of 2 conservators, myself and Zenzie, and Mike to be on hand to do any needed metalwork alterations, and there were some. Unfortunately, we don't have time to go into installation process in detail, but I would like to mention that we had strict padding and dressing protocol that we followed with each mannequin to ensure the best result. On the left, you can see a picture of Mike Hailwood during his last TT race in 1979, and on the right is our mannequin. Here are 2 more views of the same mannequin where you can see the angle of the bikes as mounted together with Hale's typical tucked-in riding position and characteristic tilt of his head, looking for the next road bend over the fairing. Here are the final views of the gallery. The general consensus was that our mannequins bring the entire display to life in a very effective way. Together with Mike, we created possibly the first fully articulated conservation-grade mannequins currently available in the UK. This project wouldn't have been possible without very close collaboration between us and having an openness to challenge and alter throughout the creative process. We would like to acknowledge and sincerely thank Zenzie Tinker for her endless support and encouragement, the fabulous ZTC team, especially Karen Bloomfield, Eva Katic, Jeffrey Major, Anna Robinson and Jamie Robinson, who undertook the conservation and mounting, TT race riders Jason Crow and Dave Molyneux, Manx National Heritage Curator Matthew Richardson, Head of Conservation Christopher Weeks, Senior Technician Colin Curry, and the rest of the Manx Museum staff. Colin for taking Zenzie and myself around the TT course at the back of his motorcycle rather fast, and the International Mountmakers Forum for having us today and turning me into a meme. Thank you.
Welcome, Ania. That was fantastic. Can you hear us yet, Ania? Can you hear us now?
Yes, hello.
Excellent. Thank you. That was a fantastic presentation.
Thank you. Mike sends his apologies and wanted me to ensure everyone that he's very happy to receive emails and schedule Zoom calls if anyone is interested and would like to ask some questions.
I have a question. You mentioned that you had the added challenge of having to remove the figures of the riders so that the motorbikes could be maintained. How often did you have to do that during the run of the show, and how difficult was it to do that?
Well, it is a permanent gallery, so we installed last year in March 2023, and that was up to museum staff. So we did showed them and run kind of a quick training session how to remove the mannequins, and we left instructions. I think they were thinking of doing it once a year, definitely, and I don't know if it happened during that time or not, but yeah, I would be interested to know if they managed.
So I also want to make sure that we compliment Mike on his amazing ball joint design. I think both the simplicity and elegance of it, but also the flexibility of it is really quite amazing, and I'm assuming that that probably really aided in your being able to pose the figures on the bikes.
Definitely, definitely. I have to say that the range of motion that we had with the mannequins is bigger than a human being, because I had a motion of basically 360 around the shoulders and hips, and everything was so easily adjustable. And yeah, it was really a kind of beautiful design, and it was a pleasure to work with.
We have a question from the online audience. Can you hear me okay?
Yes.
Now that you've seen all the resources it takes to make something so incredible, do you think that you'll be able to continue making these sort of skeleton-like mannequins for other projects moving forward?
We would like to, definitely. It's just, well, museums and institutions, if anyone is interested, you have our details. The challenge is, of course, heads and feet and hands, but we had a similar project with those mannequins in Leeds Castle in UK, and it worked really well. We managed to swap the heads for the mannequins' heads from Proportion London and fix them onto those mannequins, and because they were kind of workers, builders, we could give them work gloves and big boots. So we again managed to make it work.
Great, thank you.
Hi, I was curious, the mannequins, are they purely relying on gravity and fit to stay on the motorcycles, or is there any physical grips or anything like that?
They do rely on joints mostly, yes. They do not sit down on like a rider would on a motorcycle seat. And also there is some grip on hands, but again, it's for visuals, not for a support. And there are some brackets holding feet to the pedals, because everything is on open display and actually in a quite close proximity to the visitors. So everything has to be very, very secure. It took us a long time during the project to actually make those joints really secure and making sure that especially hips are not rotating. So we were adding additional layer, kind of grip layer that allowed us to tighten, well, allowed me to tighten those joints really, really tightly.
Thank you. Looks like it was a pretty amazing project to work on.
Thank you. Yes, yes, it was. Thank you.
I have a question. Hi, Ania, it's Rachel. Such an amazing project. I love the armadillo back that you created and the fried egg knee joints. Really great. Do you know, obviously I imagine the more you did them, the quicker they became, but could you estimate roughly how long it would take to do the torso padding once you've got the aluminium armature, how long it would take to make one?
I think when you have a method and you know what you're doing, it would be possible to make it in a day, maybe day and a half. You have to allow time for the adhesive to cure, because we were bending the card. So it's laminated 4-ply acid-free card with a layer of Evercon 100% adhesive. And then we were strapping those 2 layers of card with the still wet adhesive onto a roller, and we were leaving it overnight. So then it was this curved card. So if you take that time out, I think you would be able to make a torso in a day.
And then, sorry, like the whole body though, as well?
Oh,
like to complete the whole body,
the entire mannequin.
Yeah.
I think the first one took probably approximately 100 hours, and all in all, I think if we would divide then the hours between all 8, I think it would be around 70 to 80 hours. Again, if I would be now making them, I'm sure I could go down with those hours to potentially 40, 50. Once we had the technique, like the last 2 or 3 mannequins were really quick, to be honest, because we knew what we were doing, and it was almost like a production line. We were making several arms and several legs at the time. I think we padded all the hands at the same time. And there wasn't any creative process. It was just making. And we were changing constantly, and even during the installation, we've learned so much about what those mannequins can do and how we could adjust and change some processes.
Thank you.
Question for you, Ania. How was the ride around the course?
Oh, it was amazing. It was my first time on a motorcycle, to be honest, and it was beautiful. It was a really bright day. But it took us around an hour and part of the course was closed because of the bad weather, and the drivers, the riders do it in 16 minutes. So yes, that shows you how fast they drive.
Amazing. Well, thank you very much.
Thank you very much for having me.